This is lesson 2 now, topic 4, extracting metals, GCSE topic, Edexcel, chemistry and combined science topics here. The key learning outcomes here are definition of what a metal ore is and how to extract metals, and the evaluation of biological methods of metal extraction, which is the higher content. Let's define what a metal ore is first. It's a mineral or a mixture of minerals or a compound which contains enough metal ore which is worth extracting to make a profit. So the definition on the screen, metal ore is a mineral or mixture of minerals from which it is economically viable to extract some metals. Most ores contain metal oxides like iron oxide, zinc oxide, and the process of extracting a metal from its ore or from its oxide is called reduction. And here the definition of reduction will be loss of oxygen. So look at this example, iron oxide, reduce the oxygen or remove the oxygen. It's better to say remove the oxygen rather than reduce the oxygen. So when you remove the oxygen to make iron, that is a reduction process. How do we extract these metals? Again, a quick recap of your reactivity series, but this time I want you to note that we've included carbon in the reactivity series. Carbon sits between aluminium and zinc. You do need to know the reactivity series. It may not be given in the exam. So now you can see carbon is above zinc, below aluminium. This means all of those metals, potassium to aluminium, because they are more reactive than carbon, they will be extracted using electrolysis. All the metals below carbon, in this case zinc to copper, can be extracted using carbon, and this is a much cheaper process. And the last three metals are found uncombined in the Earth's crust, and we just need to purify those three metals. So let's look at some examples of this. So iron can be extracted from its ore. So iron oxide plus carbon will produce carbon dioxide and iron. Please note now, iron has lost its oxygen. So iron is reduced. Carbon is oxidized because it gains oxygen to become carbon dioxide. And as I said earlier, metals like aluminium, they can be extracted using electrolysis, and we will look at this later on in lesson 3 to do with oxidation reduction of metals. Electrolysis is expensive because you need electricity, which is a lot of energy needed to extract the metal. Okay, so just a quick summary then in a table, and that's a nice table for you to have in your mind. Okay, so nice exam question for you. Give reasons for your question. Give reasons for your answers. What I'm going to do here is I'm going to pause my video. I'm not going to give you the answer. You can work out the answer. Biological methods of metal extraction. This is higher content. There are two methods of extracting biologically: phytoextraction and bioleaching. Okay, the biological methods mainly make metals of what we call low-grade metals. Phytoextraction is where plants will absorb the metal compounds through their roots. So this is where you can grow plants in soils which are rich in metal compounds. And bioleaching is where bacteria absorbs carbon compounds, which produces a solutions called leachates, and then we can extract copper using displacement. We'll have a look at the two methods and the advantages and disadvantages of these methods. Both phytoextraction and bioleaching, I have summarized it here for you. The advantages are there are no harmful gases like carbon dioxide or sulfur dioxide. There is less damage to landscape because we are not mining for metals, so there's no noise pollution, and they conserves the supplies of high-grade ores. Disadvantages, both are slow because plants have to be grown. Bioleaching does not require high temperatures, that's its advantage. And phytoextraction, we can extract metals from contaminated soils. Disadvantages of both: bioleaching, toxic substances and sulfuric acid can be produced, and phytoextraction is more expensive, takes long time for plants to grow, dependent on weather conditions. Again, this is a nice little summary for you. It's normally a 4-marker question in the exams. I am going to pause the video here. The questions you should be able to answer using the notes from this video. Please note, these are the types of questions you should be able to answer. Why these processes are slow, and you should be able to write an ionic equation for the displacement reaction between copper and iron, including state. End of this video.